that the process of aging is simply the buildup of molecular and cellular errors in our bodies, like mistakes in our DNA, protein synthesis, and at the atomic and molecular levels. What if I told you that these errors aren't just a consequence of time, but something that could, in theory, be fixed forever? This is where quantum computers come into the picture. These futuristic machines are not like the ones we use today. Instead of processing data in the linear way that classical computers do, quantum computers operate in a quantum world where anything is possible, where immortality, theoretically, could be achieved. Kaku argues that there is no fundamental law of physics that says we must die. In fact, he believes that both biological immortality and quantum immortality may be possible, at least in theory. Let's break this down. Biological immortality, reversing the aging process. Biological immortality suggests that we could defeat aging by reversing the process that causes it at the cellular level. Researchers are now beginning to understand that aging is nothing more than the gradual accumulation of errors in our DNA, proteins, and mitochondria. Over time, these errors lead to the breakdown of tissues, organ failure, and, ultimately, death. But what if we could correct these errors? What if we could prevent them from happening in the first place? Some animals, surprisingly, already have this ability. Take, for example, the hydra, a tiny freshwater creature that seems to live indefinitely. Unlike humans, its cells don't accumulate the damage we experience as we age. The key to this lies in the hydra's exceptional regenerative abilities. What if we could somehow unlock this process in humans? The idea of reversing aging might not be science fiction after all, and it could mean a future where aging is a thing of the past. Quantum immortality, living in multiple realities. On the other side of this radical idea is quantum immortality, which draws on the strange principles of quantum mechanics. This concept is based on the many worlds interpretation of quantum theory. According to this theory, every time you encounter a life-threatening situation, there may be a reality where you survive. From your own perspective, you would only ever experience the versions of reality in which you continue to live. Death, in this case, would be an illusion, a concept rooted in the idea that your consciousness could shift to a parallel universe where you keep surviving. Kaku believes that understanding this idea requires diving deep into the world of quantum physics. Unlike classical physics, which operates on clear, predictable laws, quantum mechanics reveals a universe filled with uncertainty and multiple possible outcomes. The famous double-slit experiment shows how particles, such as light, can behave as both waves and particles depending on how they are measured. But what if, at a grander scale, the universe itself operates this way? The many worlds interpretation, MWI, takes this idea even further. Whenever a quantum event occurs, say, a dice roll or a decision in your life, the universe splits into multiple branches, each representing a different possible outcome. In theory, every moment of your life could create a new reality in which different versions of you exist, each making different choices, taking different paths, and even surviving or perishing in various circumstances. This means that every time you face a life-threatening moment, there may be a parallel version of you that continues to live, while in another universe, you may die. But in your mind, you would only experience the version where you survive. It's as if you're quantumly immortal. Can quantum computers help unlock immortality? Now, let's tie in quantum computers. These powerful machines can simulate complex biological processes at the atomic and molecular level, including the interactions between DNA, proteins, and the cellular mechanisms that govern aging. Traditional computers simply don't have the computational power to handle these incredibly complex systems. But quantum computers, with their ability to explore multiple possibilities simultaneously, could model biological aging in ways we never thought possible. Quantum computers might help us identify the exact processes that lead to aging. By understanding these processes at their most fundamental level, we could potentially reverse the molecular errors that cause aging and diseases. This could bring us one step closer to halting or even reversing the aging process. Who knows? Perhaps quantum computing will help us unlock the key to immortality, or at least a much longer life. Are we already quantum immortal? If biological immortality seems like a stretch, then perhaps quantum immortality is even more mind-bending. According to this theory, we might already be functionally immortal, without even realizing it. Imagine this: every time you face a life-threatening event, there's a version of you that survives. If the many worlds theory is correct, then every death is just the result of a shift in your consciousness to a parallel universe where you continue to live. But here's the big question: if this is true, why don't we remember dying before? How come we don't recall jumping from one universe to another after a fatal event? One possible explanation is that our memories are tied to each version of ourselves in a particular universe. When we shift realities, our memories of the other timelines don't follow us. This means the transitions are seamless and undetectable from our perspective. The science behind quantum immortality. Kaku emphasizes that while the concept of quantum immortality is fascinating, it is still highly speculative. The main question is whether consciousness operates according to quantum principles. Most quantum mechanics laws apply to the behavior of subatomic particles, but does this extend to the human mind? Could our consciousness also obey quantum rules like superposition and entanglement? This remains one of the biggest mysteries in both physics and neuroscience. There are some theories, like the Penrose-Hameroff theory, which suggest that consciousness may arise from quantum processes in the brain. However, this idea is highly debated, and mainstream science is still uncertain. The brain, after all, is a warm, wet environment that typically destroys delicate quantum states, making it unclear whether quantum mechanics could ever play a significant role in consciousness. Testing quantum immortality, the quantum suicide experiment. Could we ever test the theory of quantum immortality? The quantum suicide thought experiment presents a way to do so, albeit in a highly controversial and ethically problematic manner. In this experiment, a scientist creates a machine that is linked to a quantum particle in superposition, existing in multiple states at once. The machine measures the particle's state at regular intervals. If the particle is in one state, the scientist lives; if it's in another, the machine kills them. In the many worlds interpretation, when the quantum event occurs, the universe splits. In one reality, the scientist dies, but in another, they survive. From the scientist's perspective, they will always find themselves in the universe where they survive, forever, no matter how many times the experiment is repeated. In theory, this could demonstrate quantum immortality. However, the problem with this experiment is that it's impossible to measure the experience of immortality because no one else would witness the scientist's survival across realities. The limits of the theory. Even if quantum immortality is true, there are still many challenges to fully understanding it. For one, why don't we remember past deaths? If our consciousness shifts between realities, why don't we recall dying and moving to a new version of the world? Some scientists argue that this could be because memories are locked to each reality, so when we jump to another universe, we lose our memories from the previous one. Another issue is the role of probability. Over time, the odds of surviving multiple life-threatening events become astronomically small. If quantum immortality were real, why wouldn't we all survive impossible odds indefinitely? Lastly, there's the problem of the observer. While the many worlds interpretation suggests all possibilities occur, it doesn't necessarily mean our consciousness experiences all of them. Perhaps, as some physicists suggest, our consciousness doesn't follow the same quantum rules as particles. If that's the case, quantum immortality may not be as applicable to human experience as it seems. Final thoughts. Rethinking life and death. The idea of quantum immortality, while still speculative, forces us to think deeply about life, death, and the very nature of existence. If quantum immortality is real, then death may not be the end at all. Instead, it could simply be a shift into another version of reality where we survive. This challenges everything we've believed about the finality of death and the nature of our consciousness. However, the question remains, is this truly what's happening, or is it just an illusion? As scientists delve deeper into the mysteries of quantum mechanics and consciousness, we may one day have an answer. Until then, the possibilities of quantum immortality, whether biological or quantum, will continue to fascinate and bewilder us. After all, if we could truly defeat aging or become immortal in some form, how would it change the way we view life, death,